Okay, so we'll do, so most of these problems are projectile motion problems. Okay. Projectile motion, what does that mean?
Air resistance is negligible. The only force being counted for is gravity, and horizontal forces stay constant.
Yeah, and also the motion is happening in 2 dimensions. Okay? All right. So all of that is true. So a marble rolls off a tabletop 1 meter high and hits the floor at a point 3 meters away from the table's edge in the horizontal direction. So let's see what is. So it's a horizontal table, so it'll come off the table with the horizontal velocity, okay? And then when it's in air, it's on a parabolic trajectory because gravity is the only force acting on it, okay? It falls 3 meters away, so this is 3 meters away. And now you guys understand, okay. To make this fall further, what would I have to do? What are things you could do? If you throw it at a faster speed, it'll fall further. Okay? If you throw it from a higher table, it'll fall further. So the distance it's falling is related to its speed and the height from which it's launched. Okay? Now the height is fixed, so this distance is related to the speed at which it comes off. Okay? So a marble rolls off. So this is 1 meter high. It falls 3 meters away. How long is the marble in the air? How long is the time of flight? Okay, again, in all these problems, you have to draw an x and y axis. We generally draw the y axis pointing upward. Okay, and then one of the things you want to do is, here's the acceleration due to gravity. Okay, in this axis, it's 0I minus gj. G is positive. G is 9.8 meters per second squared. Okay. And generally, okay, well, so when it's the time of flight, what you want to look at is the y component of the motion. That'll give you the time of flight. So y minus y naught equal to v naught yt plus 1/2 ayt squared. Y naught is the initial height. Y is the final height. V naught y is the initial y component of the velocity. Okay. And so initial velocity is, it only has an x component and no y component. So this equation becomes, so you need to learn all of that. So there is our origin. Okay. So y is 0. Initial y naught is 1 meter. Initial y component of the velocity is 0 minus 1/2 gt squared. Okay. So we'll copy that. Okay, so 1 equal to 1/2 gt squared. T is 2 over g, and again, I'm not writing units, but everything will be in. So what is this saying?
The amount of time it took for marble to go from the table to the ground.
That's right. So that was the time of flight. Okay. What is the speed of the marble when it leaves that table's edge? Okay. So x minus x naught equal to v naught x t plus 1/2 ax t squared. All right, the velocity in the x direction is constant because the acceleration is 0. We'll say this is 0. X is 3 meters, and the x component of the velocity is just the initial speed times time. So the time is 3 meters, t was 45 seconds, and 0.45 seconds. .64 meters per second. Okay, so like we said, the further it falls, the greater would be the velocity. Okay. All right. What is its speed when it hits the floor? Okay, what is its speed? So there's the marble, and its velocity will be tangent to the path. So it has an x component of velocity and y component of the velocity. Okay. Does its x component of the velocity change along its flight?
No.
No. Why doesn't it change? Because there's no x component of acceleration. So this velocity will be the same as this velocity, which is that. So all you have to do is calculate the y component of the velocity, and then you'll get this velocity. Okay? So you can calculate its speed. All right. Vx equal to v naught x plus ax t. That guy is 0. And so this is 6.64 meters per second. So that's the final x component of the velocity. Vy is v naught y plus ay t. What is the initial y component of the velocity?
0.
0. It comes off horizontally from the table. Yes, so Vy is minus 9.8 meters per second square, and time was 0.45 seconds. Okay, so the final velocity just before it hits the ground in terms of components is that. And if you want to calculate the speed with which it hits the ground, you just have to calculate the magnitude. So it hits the ground at 8 meters per second. Okay. You guys understand this? So what are we doing? We are doing mostly projectile motion problems in 2 dimensions. Well, projectile motion is in 2 dimensions. Okay. So you have to look at the x component of the motion and y component of the motion. Any questions on that? Okay, my iPad has 8% battery, so we'll do one more problem. Okay, so this is a similar problem, okay, except that this projectile is launched from a much higher elevation, and its initial velocity is much higher. All right, before you do this problem, let's say you're going at 80 miles an hour on 95, and you stick your hand out and drop an orange. What is the initial velocity of the orange? I'm sorry? 80 miles an hour, horizontal, the same thing, okay? So same thing here. This is a plane, it drops a care package. The initial velocity of this is the same as the velocity of the plane. Okay. An airplane flying horizontally with a speed of 500 kilometers per hour at a height of 800 meters drops a crate of supplies. If the parachute fails to open, how far in front of the release point does the crate hit the ground? So the distance it travels will depend on the height it's released from and the speed at which it's thrown. And they give you the height from which it's released and the speed at which it's released. Okay, so we can calculate the distance it travels. Okay, so again, we'll set up the problem. There's the initial speed and there's the height. Okay. The initial speed is 500 kilometers per hour. Okay, kilometer is 1,000 meters. 1 hour is 3,600 seconds. 1,000 divided by 3,600. Let's divide this by 3.6 to get in meters per second. All right. I have to rush through this thing now. It's 5% battery, so the battery is dying fast. Okay, so V naught is 138.9 I plus 0 J meters per second. The acceleration is, okay, I forget the acceleration. What is the acceleration?
Negative 9.8 meters per second.
0 I minus GJ, okay? All right, now if you want the time of flight, what you want to do is you want to look at the Y component of the motion. Okay. Why do we have to look at the Y component? The higher you throw it up from, the longer it takes to hit the ground. Okay, so let's look at the Y component of the motion. Y minus Y naught equal to V naught Y T plus 1/2 AY T squared. Okay, this guy is 0, initial height is 800 meters. This guy is 0, minus 1/2 GT squared. T is 1600 divided by G. I don't want to run out of battery in the middle of the problem, okay? So 12.8 seconds. So what did we find? What is that? The crate will hit the ground 12.8 seconds later. Okay. And now let's look at the horizontal distance it travels. So x minus x naught equal to v naught x t plus 1/2 ax t squared. There's no acceleration in this direction. We'll call initial x position 0. Okay. And then what we want to do is find this final x position. Okay. We found the initial x component to the velocity 138.9 meters per second times t. Okay. And t was 12.8 seconds. Okay, 1,800 meters. 1,600 meters is a mile. Okay, so 800 meters is, you guys see those Embry-Riddle planes flying along the beach? Okay, that's 800 meters. They're not traveling at 500 kilometers an hour. They're traveling at half the speed. So if one of those guys drop a packet, that would go half a mile, but this goes a mile. A mile is from here to the speedway, to the track. Yeah. All right, guys.